This is the good stuff, I think. So, you guys have probably seen this before, as my guess, but we're going to talk about trig functions. And probably what pops in your brain most with trig functions is sine, cosine, and tangent. Those are probably the most common things. Now, sine, cosine, and tangent actually are also, all they are the ratios in the triangle is all they are. What we're going to do is we're going to deal with the right triangle. So if I were to build a right triangle over here, and it doesn't matter which right triangle you build, but they're all going to be based around right triangles. All of what we're going to do so far. Okay? Now, for our right triangle, we've got three different sides on there, and those sides have different names. I don't know if you guys remember from geometry, but hypotenuse is the most notable one, right? That's this one right here. Now, how do we know the hypotenuse is this guy right here? Longest, and it's crushed in the ninth. Okay, so those are the two things that we can automatically check real quick. These other two sides, they call legs, okay? And they're both legs, so if we did like Pythagorean theorem, it doesn't really matter which leg you put where. They're interchangeable, okay? Now, once we throw an angle in there, that determines what the legs are actually called. So if I throw my theta, let's say I throw a little theta in there. Once again, theta is talking about an angle, some sort of angle. We've been dealing with lots of thetas and whatnot lately. Now, once I throw the theta in there, that actually determines what those two sides actually are now, okay? So from theta, this side right here, this leg right here, is across from it. They call this the opposite side. So this is the opposite side. Okay? The side that's next to my theta, another word for next to is adjacent, okay? We're adjacent to each other. So we get, I'm going to abbreviate and just go ADJ. Okay? Like that.
Okay.
Math geek got that. Watch out. All right, cool. So now this is our basic triangle right here, and then there's relationships between two of the three sides. Now there's a bunch of combinations between them. Like for example, if I was talking about the opposite side and the hypotenuse. If I talk about the opposite and the hypotenuse in a ratio, that's actually a consistent trig function all the way through, and that's known as the sine function. So if I do the sine of theta equals the ratio between two sides, the two sides of the opposite side, and then the hypotenuse. So this sine is going to be the opposite over the hypotenuse. Okay, if we do the cosine of theta, cosine is the ratio between the side that's next to it, that's the adjacent side, and then the hypotenuse. So this one's going to be the adjacent over the hypotenuse. And then the last one is the tangent, and that's the other basically combination of two of those three right there. So two of those three, it's going to be, let's see, opposite over adjacent. If I go from theta, this is opposite, this is adjacent. So I've got opposite here, and I've got adjacent. SOHCAHTOA. Ooh, that sounds familiar. You guys heard SOHCAHTOA before?
Yes, and it confused me.
Yeah. Don't close the door.
It makes it harder.
Oh, I thought it was just, I thought they were being loud. Close the door. Nah, that's mean. I don't want to do that. They're not being that loud. All right, so yeah, I'm sure you guys have heard of this acronym, SOHCAHTOA. And I always said Chief SOHCAHTOA when I was in high school. That's how they taught us, but that's not PC anymore, so we can't say Chief SOHCAHTOA. So we'll say Master Chief SOHCAHTOA, and then some of the Halo people will appreciate that. Or the other one is Old Hippies Are High on Acid. Have you heard of that one before? Right? Old Hippies Are High on Acid. Okay, so there's a couple different versions out there, but you know, do what you want with it. But this is actually an acronym to help you remember the order of what's going on here. So we have the sine function, the S right here, the S is right here, and then O and then H. So there's the SO part. There's the SOH part of it. Okay? So we got SO, and then the CA is right here, that's CAH, and then the tangent is TOA. Okay? So that's what that's short for. Okay? Does that make sense?
Yeah.
Okay, now, there's ratios in this triangle that we haven't actually talked about yet. For example, if I just looked at this triangle right here and said, all right, I'm going to pick two sides and put one over the other. Okay, well, I started with opposite over hypotenuse. What if you had flipped that over? What if you had gone hypotenuse over opposite? It wouldn't have been the sine function anymore. It's got to be in that order. So there's actually three other trig functions that you guys have probably never heard of before, is my guess. Everybody's probably heard of sine, cosine, and tangent, right? There's actually three what they call reciprocal trig functions, and that is the same exact ones here, except for we flip them over. Okay. Now the new part for us is the hard part. Is going to be remember what they're called and which one goes with what. Okay. This is the sine. Now notice I don't say sin. Okay. Don't say that. It's horrible. Don't say cos and don't say tan. Okay. We just don't do that. Okay. Even though a word is abbreviated, it doesn't mean we read the abbreviation. Right. Like when you say, what is it, etc, when you say etc at the end of a sentence, you don't say ect or esk or whatever it is, right? I mean, we say the hispa though. Funny how that works. But we shouldn't, right? It's just because that's so long. Anyways, this is the sine, cosine, and tangent. Please use the appropriate words, okay? And usually people are okay on the first three. They screw up the reciprocals all the time. Okay, I'm going to start with the tangent right here. The tangent, the reciprocal of tangent is called the cotangent. Super hard.
With what?
It's called the cotangent of theta.
We have
Okay.
a one.
What's that? We have three new ones, actually.
Oh my God.
That's what I was just explaining. But if I erase this triangle, just so I have some room here, the cotangent and the tangent, they're actually just reciprocals of each other. So if I'm going in this direction right here, these are the reciprocals. These are the reciprocal functions of them, okay? Now, reciprocal, you guys probably remember that from the past, right? What does that mean, reciprocal? Flip, right? We're flippercal, as somebody probably said junior high. That just means flip over this ratio. So we're going to do the adjacent side over the opposite side. Okay, so the cotangent, please don't say cot. Okay, this is the cotangent. Okay, it goes with the tangent. It's the reciprocal of the tangent. We just flip over whatever that is. Okay, so the TOA part at the end, if it's cotangent, we just flip that over. So we're going to do A over O. Okay?
Is that sine the negative first?
No, it's not. No, it's not. And we'll explain that as we get a little closer. Okay? All right, now, the other two, these are backwards for what your logic brain would tell you. One of them is called the secant, and the other one's called the cosecant. You've probably heard of the secant before, maybe in geometry. You remember what a secant was? There was a tangent line that touched the circle at one point, and there was a secant line. So that was the one that touched the circle at 2 points. Okay, so basically a chord. You guys remember chords going across the circle? Anyways, that's a secant line. But the secant, you would think if I have secant and I have cosecant, which one do you think? Which one would go with?
The secant's going to go with the cosine.
Yeah, it's backwards only because I just told you that. Yeah, the sine you would think goes with secant, and then the cosine goes with cosecant. Unfortunately, it doesn't work that way. It's backwards. So the sine, the reciprocal of sine is called the cosecant. Okay, and I'll write it out up here. This is the secant. S-E-C-A-N-T. Okay. Now that's the full out word of it. Now if I'm doing the cosecant, we just throw a little CO in the front of it. That's the cosecant function. Now the abbreviate, we don't want to write that out every time. So the cosecant is actually CSC. Okay. So we have what's called the cosecant function. Please don't say cosecant. Okay. Just sounds silly. We're going to reciprocate opposite over hypotenuse. So we're just going to go hypotenuse over the opposite. We just flip that guy over. That's all we have to do. Whatever that one is, we just flip it over. Okay, now the other one's not the co-function. It's called a secant function, and this is going to be SEC. That's called the secant, and that's short, an abbreviation for secant. Please don't say sec. You sound silly. I'll laugh at you. Okay, this is the secant. The secant goes with the cosine, and we just reciprocate. So it's going to be the hypotenuse over the adjacent. Okay, now unfortunately there's no fancy acronym to remember like the orders of these guys. You know, like there's no SOHCAHTOA for the reciprocal function. If you want to try to make up your own, that's fine. Go for it. So it'd be like cho and then sha and then cow or what. So if you want, there's nothing that works out very good. So just so you guys know. So all you have to do is remember what the SOHCAHTOA ones are, and then just be able to flip them over, knowing which one goes to what. Okay. So let's go ahead and see how this works. Just real quick like. And let's start with the right triangle. Looks something like so.
What?
Okay, so let's say this is our right triangle, and I've got a couple of the legs on the right triangle. I got 5 and I got 12. And I want to find the 6 trig functions of this triangle if I can. Now, all a trig function is a ratio of 2 sides. It's one side over the other. That's all it's really standing for. Okay. Depending on how big those sides are, will depend on how big the angle is. So that's the relationship between those. Okay. So if I'm going to find all the trig functions, I got to do the sine of theta, cosine of theta, and then tangent of theta. And I always start out with the big 3. Start out with those guys, and then just try to reciprocate from there. Okay. So if I want to do the sine function, I need to go the opposite of my theta over the hypotenuse. Now, opposite is 5. That's not bad. Over the hypotenuse. Now, I don't know what the hypotenuse is yet, right? So I better find it. Pythagorean theorem, yep. A squared plus b squared equals c squared. So if I did that on there, I'm just going to cheat and tell you it's going to be 13. You guys can all do Pythagorean theorem, right? I hope so. Okay. All right, so the sine is going to be 5 over 13. That's the sine function. That's the ratio between the sine. Okay, so depending on how big that ratio is going to tell us how big the angle is. And the sine function figures that out for us, which is kind of cool. All right, now the cosine of 45. Cosine is adjacent over hypotenuse. Adjacent side is 12. Hypotenuse is 13. So this would be 12 over 13. And then the last one's tangent. Tangent is opposite over adjacent. Opposite is 5. And then adjacent is 12. Okay? Now to find the other three, that was the big three. That's SOHCAHTOA. Okay? Once you have that, the other three are pretty easy to do. We just have to flip all those fractions over, and we just have to figure out which one goes with what. I always start with tangent. Tangent goes with cotangent. That one's the logical one out of it. And so I'm just going to flip over 5 over 12, giving me 12 over 5. And then I figure out which one, either the sine or cosine, goes with either the secant or the cosecant, and it's backwards, okay? So that means that the cosine is going to get the secant function, secant of theta. So we're just going to flip over 12 over 13. We get 13 over 12. And then the sine function, that goes with the cosecant. And that's going to be CSC. And we're going to flip over 5 over 13. We get 13 over 5. Okay, we're feeling pretty good about this. It's not too bad, I hope, so far. We got a fair amount to get to still, but I just want to make sure we're good with the basics. You guys have seen at least this, right? Some of you got basically half of it is kind of new for you. Okay, let's go ahead and look at the dreaded special right triangles that you guys learned in geometry. I know you did, but it's probably been a while. These two triangles we're going to use a ton throughout this this whole chapter, so they're going to be just probably ingrained in your brain. One of them is a 45, 45, 90.
Yeah. Because you're already.
And the other one is 30, 69. And we're not going to do quite as... I'm dying to shut that door. I'm just not going to.
You press.
Shut that door.
There's a pen in the back.
I'm okay.
Yeah.
I'm okay. It's all good. I'm happy.
No, you're not.
Explode here.
Close the door out.
No, let's be nice. It's the people in the hallway, I think, mostly.
No, funny.
It's all good.
It's across the hall.
Oh, it is? Sure. A little educational respect.
Don't say no.
Interrupting the educational process.
All right, here we go. So 45, 45, 90. Now, I don't think you really need to memorize these because you can always build them every time. But memorizing is probably what's going to happen, okay? If I were to build this actually comes from a square. So if I take a square and I throw a diagonal across it, like so, all of a sudden I've got a 45, 45, 90 degree triangle, okay? This is 90 because it's a square. And then this diagonal actually bisects an angle on the inside, so it's going to be a 45 here and a 45 there. So I have a 45, 45, 90 that's from a square, okay? Now on a square, what do we know about all the sides?
Well,
They're all the same, okay? I'm going to cheat and make them all 1, just to keep it basic. Okay, so all the sides are 1. Now what about the diagonal?
1 or 2.
What is it?
Right, 2.
That's right. Radical 2. Anybody else not? Okay, this is how I got it. 1, 1, 2.
1 divided by 2.
Do what?
No.
No, not quite.
No.
Forget about the angles. How can I find the third side? Right triangle. Pythagorean theorem, right? 1 squared plus 1 squared, right? 1 squared is 1 plus 1 squared is 1. 1, 1 are 2. Square root of 2 is square root of 2. So this is going to be the square root of 2. So the diagonal is not 2, which is common. Some people probably already wrote it in there. It's the square root of 2, okay? So 1, 1 square root of 2. This is one that we're going to want to know how to do, okay? Because a lot of the stuff we're going to do in this chapter is not a calculator-based type problem. So this is one of the big ones that we're doing, okay? The other one is a 3690. Okay, this one's a little tougher to get. The square is pretty easy. Just take a square, cut it in half, call it good. Okay, now the 3690 actually comes from an equilateral triangle, which looks like this. And in an equilateral, we know all those angles are the same. So I know this is 60, and this is 60, and that top one's 60. Then if I throw this right down the middle, that's called an altitude or a median, or a perpendicular bisector.
or a bajillion other names.
Or an angle bisector, or there's got lots of names for it. But anyways, 1 past 90, that forces this angle to be 30. Voila, we have a 30/60/90. Okay? Now, I like to avoid fractions, so don't write this little part down. If I did the same thing I did on the square and made all those guys 1, right, how big would just this side be? I don't like fractions. Let's not do that. Okay, let's pick a different number. 2. Good guess. Okay, let's pick 2 here, 2 here, and 2 here. How big is this side? 1. Okay, so that's pretty good. So I've already got half the triangle, or 2/3 of the triangle. Awesome. By force Americans, bad fractions. That's right. Okay, so let's go ahead and pull that triangle out. This triangle is right here. It's a 60, it's a 30, it's a 90 right here. The hypotenuse I'm making 2. The short side I'm making 1. And if I do Pythagorean theorem right there, right, I go 1 squared plus x squared equals 2 squared. So it ends up being the square root of 3 if you do a little math there. Okay? Now the way I remember this one, I always remember 1, 2, 3. I'm just counting 1, 2, 3, and then I just throw a square root on the 3 right there. Okay, so 1, 2 square root of 3. Call it 3. It's always the square root of 3. It's always 1, 2 square root of 3, no matter what. Okay. How's the square root of 3? If let's say this was x, right? It would be 1 squared plus x squared equals 2 squared. Right? 1 squared is 1 plus x squared equals 4. Subtract 1 to get 3 square root.
I put 2 as the.
That's all right. Yeah, now it's always tough to remember where the things go, right? Over here it's pretty easy. You know the 1 and 1 go on the legs because they're equal. I mean, they have to be, right? Over here it's always tough to remember what goes where, right? Well, 1 is my shortest side, right? And it's across from the 30. It's across from the smallest angle there. 2 is my biggest side. It's across from the 90. Square root of 3 is the middle number, right? Square root of 3 is like 1.73 or something. And so it's right in between 1 and 2. Okay, so 1.73 is it's in the middle, so 60 is going to be our good answer. Okay? All right, cool. So that's another triangle that we're going to heavily use. Okay, so let's go ahead and find some things out. And this is all without a calculator, hopefully. Let's say I want to find the sine of 45 degrees. How am I going to know you used a calculator? We'll show you. Okay? Here we go. I'm going to go sine of 45, and I get 0.707. You put that on there, and you are going to get it wrong. Okay? Obvious, 0.7. That's the correct answer. 0.77 is the right answer. But if you put that, it's going to say don't use calculator, so obviously. Okay, so this is how you're going to have to do this. If you want to find the sine of 45, build a 45-degree triangle. Okay, so if I just draw a right triangle over here, and I want to make it a 45, 45, 90. So I'm going to put a 45 right here. This is 90. And I've got a 45 up here. I'm not going to write that one in there. I'll need one of them to help me out here. I know that my legs are the same. Those are both 1s. My hypotenuse, if you forgot, you could always do Pythagorean theorem, but that one's going to be square root of 2. So now if I want to find the sine of 45, the sine of 45 is not going to be too bad now. Sine stands for the opposite over hypotenuse. Opposite side is 1. Hypotenuse is square root of 2. So this is going to be a 1 over the square root of 2.
That's the answer.
Got almost. So close. It's looking for the ratio, exactly. It's looking for what my answer is for the ratio for sine of 45. Okay? Now, 1 over square root of 2, if I put that on my calculator, 1 over square root of 2, that's correct. That's the right decimal interpretation. But there's something wrong with this picture, right? The math gods decided that was bad math grammar. To have a square, you can't have a square in the denominator, right? It's just like wearing suspenders and a belt. It's just overkill. Okay? So, to fix this, we need to multiply the top and the bottom by square root of 2. Anybody ever tell you that? You shouldn't wear suspenders and a belt.
All the time. Because I don't wear suspenders.
No. It's like they're canceling each other out. Yeah. All right, so 1 times the square root of 2. Anything times 1 is just the square root of 2. That's good. And then the denominator, square root of 2 times itself, that'd be square root of 4. Square root of 4 is 2. So this is going to be the square root of 2 over 2. Okay, that's the answer I want. I'll give you half credit if you get here. You take it all the way, which is super easy to do. You get all your credit. Okay, now I can double check my answer. Square root of 2 divided by 2, 0.707. Okay, so I get the same thing.
Okay. Are they going to be like,
if they're going to say without a calculator, it's guaranteed to be a 30, 60, 90 or 45, 45. It's got to be one of those two. Okay? All right, so that was the sine of 45. I think we're all feeling semi-okay about that. But let's say I wanted to do the
What's triangle?
The secant of 45. The sine of however big the angle is going to tell you the difference in the size, the ratios in the size. So the bigger that angle gets, then the bigger this opposite side gets, the hypotenuse stays the same. So all it is a way for us to figure out an angle, and then based on having two sides of a triangle, or the other way around, figuring out a size based on how big the angle is. Okay? Because if I take this angle right here, if I take this angle and shrink it down, that's going to change the opposite side, right? And so that ratio is going to change, meaning my sine function will change. So that's kind of the power behind it. Is it calculates that for us. It says, all right, well, if I know the size, I can figure out the angle, which is awesome. So, yes, ma'am. I can make them whatever I want, really. I could have made it 4, 4, and then this would be 4 square root of 2 if I did Pythagorean theorem. But I always start out, you get the same, after you reduce, you get the same answer. Yeah. So, but on the two triangles that I said we should probably know, I'm always going to put a 1 and a 1 here. Just because they're easy to work with. So I just picked 1. Okay, let's go ahead and find the secant of 45 now. Now, the secant of 45, we have to figure out which trig function that goes with, and then flip it over. It's the reciprocal of it, okay? So if I once again built that exact same triangle, 45, 1, 1 square root of 2, I want to do the secant function now, okay? Now, you got to think of which one the secant goes with. The secant goes with the cosine, okay? So I want to do the opposite of the cosine, okay? I want to do hypotenuse over the adjacent, okay? The hypotenuse for this one is square root of 2. The adjacent to 45 is 1. So this would be square root of 2 over 1, or just the square root of 2. Okay, now we have a small problem on this one. How the heck do we put that on our calculator? Notice that there's no secant button. There's no cosecant button. Okay? If you want to type in secant of 45 in your calculator, this is how you have to do it. Secant is, it goes with which function? With the cosine, okay? So what I do is I go 1 divided by the cosine of 45. Remember, it's the reciprocal, which means flip over. Okay, so if I go 1 over cosine 45, I get 1.41, which if you check, square root of 2 is your good answer. The common mistake people make is they go second cosine, cosine of the negative 1 of 45, and it says, whoa, can't work. And I'll explain why that doesn't work a little bit later.
So normal cosine?
Say it again. So it's 1 over cosine of your angle. It's the reciprocal of whatever one it goes with. Okay?
So it's 1 divided.
So it's 1 divided by the cosine of that. Yep. So that little negative 1 button we're not using yet. We don't have to use that yet. We'll get that. Okay? All right, let's do a couple more until we get the general idea here of this guy.
Is that for all the 1 divided by the 1?
All right, it's for all the opposites, yep. So if you want to do the cotangent, you do 1 over tangent. If you want to do the cosecant, you do 1 over sine. Okay, so let's do the tangent of 30. So first off, we've got to build a triangle. We've got to build a 30, 60, 90 triangle on this one now. So this one was a little taller. And if your picture's not perfect scale, who cares? It doesn't matter. As long as your sides are right, you're going to be okay. Okay? This looks like my 60 right here. This looks like my 30. And I always remember it's 1, 2 square root of 3. 1, 2, 3, and I throw a square root on. 1 is the shortest side, so that's going to be this across from the 30. 2 is the biggest, hypotenuse. Square root of 3 is the oddball.
Yep. Is that smaller leg always going to be half of the longer leg?
It's always half the long leg, no matter what. Yep. All right, so again, now, kind of the question you were asking, why did I pick 1s? I'm always going to pick these as well, right? This is always going to be 2 and 1 and square root of 3. That's going to be constant all the way through. Okay, now I got to do the tangent of 30. Well, 30 degrees actually changes where your theta is, where your angle is, right? So actually our theta is up here now, which changes what our sides are. 1 is now the opposite, square root of 3 is the adjacent, and then this is still the hypotenuse, okay? So if I'm doing the tangent of 30, tangent says opposite over adjacent, opposite's 1, adjacent is square root of 3, and I'm feeling good.
So the hypotenuse isn't the hypotenuse?
The hypotenuse is still the hypotenuse. Yep, 2 is still the
The
hypotenuse.
opposite.
Although I don't even need the hypotenuse on this one, right? Yeah,
The opposite and adjacent.
opposite and adjacent for tangent. Yep, because it's TOA, so it's OA for the tangent. On the
The
SOAP TOA.
shortest side isn't always.
Correct. It totally depends on which angle you're going from. Since I'm going from the 30, I have to use my theta up here, and that's the angle. So now this is now my opposite. It's opposite of 30, right? And then this is the adjacent next to it, and then that's still the hypotenuse. Okay? Now I don't want to leave my answer as 1 over square root of 3, right? We got to fix that. So we're going to multiply this by square root of 3 over square root of 3. And so I get a square root of 3 on the top, and I get divided by a 3 on the bottom. Square root of 3 times square root of 3 is just a regular 3. Double check that, tangent of 30, and I get 0.577. You put that on a test, you get it wrong. But double check square root of 3 and then divide that by 3, the exact same decimal. Okay, so I'm feeling pretty good about it.
So we have to do the reciprocal for each other?
This isn't a reciprocal function, this is just tangent. Now, let's say I wanted to do cotangent of 30 now. Okay? If I wanted to do cotangent of 30, okay, good. Cotangent is just the flip of 1 over square root of 3. So this is just going to equal the square root of 3 over 1. It's going to equal the adjacent over the opposite. Okay, now square root of 3 is 1.73. If I do cotangent of 30 on my calculator, I should get that 1.73. Okay, now to do that, for a cotangent, you have to do 1 divided by tangent. 1 divided by tangent of 30 degrees. That gives me the cotangent. Whoa.
Look at the negative.
Of course I did. Why did I do that? Yeah, that's bad. Sorry. 1.73. Okay, which is the square root of 3. If you wanted to do it, no, fine, I'll do it. Since you asked. Okay, the exact same decimal. Identical. Okay, we feel pretty good? Not too bad. We're flying right through this, I hope. All right, cool. Now let's work backwards a little bit.
Now it's the inverse.
Just a little bit. Now it's almost time for the inverse. Good job.
When we get to the decimals at least.
Okay, I'll show you how these inverses work, and then I got a couple little triangle solver type problems for you real quick, and then we'll be good to go. I don't either. Now, but once again, these are without calculators. We want to try to do as much of this as possible without a calculator. Now, if I say without a calculator, which triangles should be jumping in your brain?
13,
30, 60, 90, 45, 45, 90, right? We should be thinking about those, okay? So somehow I got to have those in my mind, or maybe referencing your notes for this, okay? I want to figure out where the sine of theta equals 1/2. What I'm looking for is how big my angle is. So now I don't know which triangle to build, so I'm just going to build any right triangle, like so. And I hope that it's either a 30, 60, 90 or a 45, 45, 90. One of those two, okay? Now the sine of theta equals, well, I got two sides here. What do those sides represent as far as the SOHCAHTOA goes? Opposite and hypotenuse, okay? So if I put my theta somewhere, doesn't really matter where you put it, I know that the opposite side is 1, it's over here, and I know the hypotenuse is 2. So I know that that's a 1 and a 2 right there. 1, 2, radical 3. This one's radical 3. You can do Pythagorean theorem if you don't trust me there. Yep. This is opposite, and this is hypotenuse. That's what the sign stands for, right? It does. True. Let's say I built my triangle like this. Everybody's going to have a little bit different triangles. Let's say I put my theta up here, right? The opposite side is 1. Where's the opposite side now? On the bottom, right? And the hypotenuse is 2, and then my square root of 3 is here, right? The thing is it won't matter. It won't matter where you put your theta, because what matters is what's across from it, right? Now, which angle is across from the 1? What kind of triangle is this, by the way? 1, 2, square root of 3. 30, 60, 90, okay? So how big is the angle across from the 1? 30. So I know theta is 30 degrees. Okay, so that angle has to be 30 degrees. You don't want to put the theta where the 90 is, because then your opposite side and your hypotenuse are the same thing, right? Yeah, so we can't do that. You can never go from the 90. Okay? But it doesn't matter. It doesn't matter which one of those two angles to go with, is what I was trying to say. Okay? So I know that theta is 30. So I know theta equals 30 degrees. Okay, so that's not too bad. If you can figure out which triangle it is and which angle theta is supposed to be, you're going to be good to go. And if it's without a calculator, it's going to be one of those two triangles for now. Okay? For everything that we're going to do. All right, now if I wanted to check my answer there, I want to get theta by itself. I want to get rid of this sign. This is where you use that actually sign to the -1 button. That'll undo a sign for you. It'll work backwards for the sign. So if I go sign to the -1 of 1 divided by 2, I should get 30. Okay, so I get my angle back. Okay, if you ever want to find an angle, that's when you use that sign to the -1 stuff. Okay, now that one was a pretty basic one. They're going to try to trick you, obviously. That's their goal. Yeah.
I don't get why the triangle couldn't be 45, 45, 90.
Because let's say this was 45 right here, right? And this is 45. Don't these two sides have to be the same? Right? So since these two sides are the same, it can't be a 45, 45, 90 would be 1, 1 square root of 2. Okay? Cool. Now, that one was, I don't want to say basic, but fairly basic. Let's go ahead and do one that's a little tougher here. Let's do the secant of theta equals the square root of 2. So once again, I want to try to build a triangle on these, okay? And it doesn't matter exactly what kind of triangle you build, as long as it's right. So throw your right, and by right I mean right triangle, not correct. Right? Thank you for that. Okay, cool. So I got a 90-degree angle. Let's see. So now I'm put my theta wherever. I'm going to throw my theta right here. Well, can't put it at the 90. Sorry. One of the two acute angles. One of those two. And now I got to figure out what the secant is. Now the secant is something over something. The problem is I don't even have a fraction here, right? What if I made a fraction? What would the denominator be? 1. Okay, so I technically still have a fraction there, okay? Now I got to figure out what the secant goes with. Secant goes with cosine, right? Cosine's adjacent over hypotenuse. This would be hypotenuse over the adjacent. Okay, are we okay with that? Hypotenuse and adjacent. That means, say it again. Adjacent is next to, okay? So hypotenuse is square root of 2, so that's this guy. And the adjacent is next to. So the one next to theta is this one right here. So there's got to be a 1 here. We did Pythagorean theorem. Theta is 45 degrees. So I get 45 degrees.
How did you check that?
How would you check that on your calculator? Good question. Now, secant goes with the cosine, right? And so you'd actually have to flip that over. You'd actually have to go 1 divided by the cosine. Of the inverse cosine of the square root of 2.
I see.
I still get why you know it's full. Why would you get the inverse?
You need another parenthesis.
Yeah.
No, that's not why.
Yeah.
It's not like that.
Oh, you can't do this on your calculator yet. Not yet. I haven't showed you a trick yet.
I hate to.
He shows.
Not yet.
Why not?
I can't show you because I can't.
It's again.
Because I can't. I can't.
Is it part of this lesson?
I can't.
Can you just do 1 over
Nope.
cosine of 45?
Nope.
1 over cosine of 45?
Nope.
And see if it equals radical.
You can do that. You can do that. That'd be a good idea. His idea was just to check your answer. If you plug 45 back in there, you can do that. That's legit. That's okay. I'm happy with that. I can't show you the other shortcut yet, though. You'll be lost. Yeah.
Can you go over the tangent one or the
Oh my gosh, really?
whatever the real name?
Cotangent.
I didn't want to say cot.
You don't want to say cot. Yeah. It depends on which one they give you. So like here they give you the tangent, so you have to use the tangent.
Okay.
Okay. So it just depends on what they give you. Now this one's kind of tough because they give me tangent of theta equals the square root of 3 over 3. I promise we're almost done. We're close. So let's say it again. No, because if I were to build this triangle right here, let me just say I built a generic triangle. Right angle right here. Now tangent stands for opposite over adjacent. So this is the opposite side, and this is the adjacent side, right? So we got opposite. Opposite would be here. If I put my theta here. Square root of 3. Then the adjacent side would be a 3.
Wait.
Does that look like any triangle that we've done so far? Any of those have a 3 and a square root of 3 in it? No, we got 1 square root of 2, and we got 1 2 square root of 3. So we don't have that actually. We don't have that triangle yet. That means we have to tweak this just a little bit. Square root of 3 over 3. Remember we got that answer, square root of 3 over 3? What was the answer right before we got this? It was 1 over square root of 3, right? So if I change this to 1 over square root of 3, wait. This is why. Multiply the top and the bottom by square root of 3 over square root of 3. That would give me a 3 on the top, divided by 3 square root of 3. The 3's cancel, so I get 1 over square root of 3. Okay, so going backwards, exactly, going backwards. Because I didn't recognize the triangle with the sides that they gave me, right? It wasn't one of those. So I knew I had to tweak it a little bit, okay? So to tweak that, you just multiply top and bottom by square root of 3. And so I get 1 over square root of 3. Now I can build my triangle a little better, right? So when you build your triangle here, if I put my theta and 90 here, 1 is now the opposite side. Square root of 3 is the adjacent side. Now we're talking. Now we're talking this being 2.
Couldn't you already know that since there's going to be a square root of 3, that's going to be 36?
You can't, true. You still got to determine which one it is, the 30 or the 60. But you have the 50-50 shot.
So it's 60.
You can still figure that out, though, if you were thinking. Is this for square root of 3, right? And this for 3. Which one's bigger? This one, right? So this is smaller, so which angle does that have to be? Smaller, so 30. So automatically it's got to be the smaller one. Okay. So you just like okay. All right, last one real quick here, and then we're done. Okay? Oh, what's the degree? 30. 30 it is. Yep, it's got to be because the 1 is right here. Let me erase this. The 1 right here, that's the shortest side. So the 30 is the smallest angle on a 30, 60, 90. It's got to go there. 60's got to go here. So life is good.
That 1 2 works for 36.
Yes. Yes. And then 1 square root of 2 for 45, 45. It's square root of 3 over 3. But that is right for the other
So
angle.
I use the new converted one.
Yep. Okay, 2 of these real quick, and then we'll be done. These will be so fast, I promise. A little bit of triangle solving here. This will be fast. Top angle's got to be a 45. Yeah.
Where we find the angle or the...
Now what I would do is I would figure out which trig function they're actually asking me to look at here. Okay, so from 45 degrees right here, from this angle, right, what side did they give me? Opposite and hypotenuse. So which trig function? So sine, good. So if I did the sine of that angle, 45, that's my theta, equals opposite over hypotenuse. So this would be opposite over hypotenuse. Sine of 45 equals x over 20.
That's the answer?
Well, no, if we want to solve for x now, I want to find out exactly how big that side is, right? Now I'm going to let you use your calculator on this one. Figure out what the sine of 45 is.
No.
It should give you 0.707.
0.707.
Okay, 0.707. And that equals x over 20. So this is 0.707 equals x over 20. And now I just got to solve for x. So how do I get rid of that little 20 right there? Multiply by both sides. Yep, so I'll multiply this by 20 and multiply this by 20. So 14.14.
Can you multiply both sides by 20?
Multiply both sides by 20. These 20s cancel, so all you're left with is x here. And 20 times that. Yes, super smart, so you can do that. Divide by square root 2? Yes.
Is the answer 10 squared root 2?
The answer is
By 10 squared
yes.
root I calculate on that.
Cool. That's awesome. Take it out of math print or whatever the heck it's called. Yeah, what's up?
Can you put a 1 below the sine 45 and cross multiply?
That's a great idea. Perfect. I love it. Now another way to think about that, there's a shortcut for cross multiplying too. Somebody probably taught you in middle school somewhere. They said multiply your cross products, multiply those, and then divide by the oddball. So if you go those two multiplied, divide by 1, effectively it's the same thing. Okay? Now that's really going to help you for the next problem that I'm about to do, and the last problem I'm about to do for today. Last one. This is the first time I've said last one today.
Yeah.
Just so you know. I said the last type.
Whatever.
You said last before though.
Last one. Promise.
Oh.
Sorry. So I'm going to 30.
Okay, so which trig function is that?
Okay.
Okay, so tangent of 30 equals... Ooh, now the x is on the denominator. That messes with people just as much as having the x on the right side. They both screw people up, right? Drives people nuts. It's okay that the x is on the denominator. It really doesn't matter. Now, I like what Megan said. Well, why don't I just put this over 1 and then cross multiply it? Great idea. Now, the shortcut from back in the day was to multiply the cross product, so multiply 10 and 1 together, and then divide by the odd one. Okay, so we're going to go 10 times 1, which is 10, divide by tangent of 30. Okay, now if you don't like that, you can literally write that all out. You can cross multiply. 10 multiplied by 1 equals x multiplied by tangent of 30. 10 times 1 is 10 equals x times the tangent of 30. And then I would actually divide by tangent of 30 to get this x by itself. Okay, so divide both sides by tangent of 30. It would be 10 divided by tangent of 30 equals x, which is the same as using that little cross multiply shortcut somebody taught you once upon a time. Okay, so 10 over 30 is going to be a little bigger, so what are we at? So it'd be 10 squared root of 3, yeah? 10 squared root of 3, so 17.3? Is that what you got? You guys get that? Okay. So x equals 17.3.
Wait, so which ones can I use the calculator on and which ones can't?
The ones that they tell you you can and the ones they tell you you can't. Good.
Oh, there it is.
Well, how do you double equal? Really?
Hey, Yogi, want to see a little bit of that?